All right. Good morning, everyone. Welcome to the March 2026 Water Conditions Monitoring Committee meeting. My name is Emily Adrid, and I'm with the Colorado Water Conservation Board. Today, we have presentations from the Colorado Climate Center and the USDA's Natural Resource Conservation Service. But before we start, I think I will pass it over to Nate Pearson from the DNR with an announcement. So, Nate, if you just want to introduce yourself, and that'd be great.
Yeah, thanks so much, Emily. Really appreciate it and good to see everybody. Thanks for joining today. Um, so folks may have already seen this morning because a press release went out, but as of this morning, Governor Polis has activated the state's drought task force, and the task force will be meeting within the next 30 days to start uh, receiving information from the WCMC, start planning potential future actions, coordinating statewide drought response. So I just wanted to share that news and appreciate Emily and Kat and Sam and everyone at CWCB's work making this happen and a lot of work to come. I'll also just say, both Governor Polis and DNR Director Dan Gibbs, as well as our other agency heads, Department of Agriculture, Department of Homeland Security, and Emergency Management, Department of Local Affairs, everyone has been really, um, you know, really looking for information about the drought, really concerned about the impacts. And I think this this discussion about launching the task force has been really, urged from the highest levels of leadership within the state. And so we're really excited to get started. It's going to be a really challenging year, but we're hopeful that the drought task force can help coordinate, everything from local to statewide response actions and hope that folks on this call stay engaged throughout the process. And um, yeah, thanks again, Emily, Kat, Sam, everyone from CWCB for the work that's already happened and the work to come on this. So thank you.
Awesome. Thank you, Nate. I think we also have Katie Weeman, just for a follow-up comment.
Yeah, thanks, Emily. Hi, everybody. I'm Katie Weeman. I'm the communications director at CWCB. And yep, like Nate mentioned, we had our press release go out this morning at 8 a.m. Through the governor's listserv and through the CWCB listserv. So if we have any media on the call or who listen to this later, feel free to reach out to me with any media requests that you have. You can email me at catherine.weeman@state.co.us. I'll put that in the chat as well. And then if you want to stay up to date with future press releases from us or future newsletters where we will have updates from ongoing efforts from the Drought Task Force, we have a listserv you can sign up for as well. I'll pop that in the chat as well, but you can also find it on our homepage. If you scroll all the way down, there's a newsletter subscribe button. So sign up for that if you'd like. And I think that's about it for me. I'll turn it back to Emily.
Great. Thank you so much, both of you, Nate and Katie, for all of your work and support so far with the Drought Task Force. And we're kind of just getting started. So, um, again, appreciate you guys being here. And I think now we can pass it over to Peter from the Colorado Climate Center.
All right. Thanks, Emily. Okay, I know it's not in present mode yet. We'll go ahead and get that started. All right. Can you hear me and see my slides okay?
Yes.
Excellent. Thank you so much. I'll open this morning by saying that I wish I had more good news, and I'm sure that our next speaker feels that way as well. Um, Tough update today with the crazy, much above normal temperatures and very dry conditions that we have been experiencing this winter and at the start of spring. The photo I chose here, this cover photo, is actually, it was taken by Ali Mazarek in our office just last Thursday evening, after some severe wind gusts knocked over some quite a few trees and fences in Fort Collins. And you can also see buds on these big trees in the oval. Things are leafing out, and that's really, really early for our area. And that's probably something that folks across a lot of the state have noticed as well. The wind won't be the main story today. It'll be the warm temperatures and very low precipitation slash snow, but definitely a part of the story. So I saw a lot of names popping up in the chat, and I don't know all of you. So if you're new to WCMC, welcome. The Colorado Climate Center typically has somebody do a quick update on climate conditions, looking at the last couple of months and kind of setting what we've seen in a climate context. Then we look at drought conditions and some of the factors driving what we see on the current US Drought Monitor map. And then we'll take a look at the outlook for the weather going forward, starting with just kind of the 7 day and 8 to 14 day outlooks, and then looking at some of the longer term seasonal outlooks. So again, welcome. We'll start with recent conditions. I mentioned the budding trees. This is just a map from the National Phenology Network that shows the spring leaf index, or kind of how the leaf out date compares to normal. And you can see that we've got leaves on our trees over 3 weeks early for a lot of Colorado, including the Northern Front Range. So let's dive into some of the conditions that allowed that to happen and take a look at where we might be going from here. All right, this is one of what we call our quadrant charts. So here we're looking at statewide temperature and precipitation conditions for the last full calendar month. So we're looking at February here. The horizontal axis shows you accumulated precipitation in inches, and the vertical axis shows you average temperature in Fahrenheit. The cross hatches that you see show normal conditions, at least relative to the 1991 through 2020 period. And then each dot is labeled and shows a year, and the star shows the current year. So 2026 is way up at the top because 2026 was the warmest February on record at 7.6 degrees above our 1991 through 2020 normal, 9.2 degrees above our 20th century average, and a little bit on the drier side too. There were some areas of the state that did okay for precipitation in February, but did not get anywhere near enough precipitation to really make up for the deficits that had already been built over the course of the winter. So if we break some of this down spatially, here is a map showing departure from normal temperatures for February 2026. And you can see that much of the eastern side of the state was 8 or more degrees above normal, and parts of the northwest quadrant of the state as well. The mountains a little bit closer to normal, but still well above normal. So that's temperature departures from normal relative to the 91 through 2020 average. And 7.6 degrees Fahrenheit, if we were just looking at a day or two of data, 7.6 degrees above normal wouldn't be that big a deal. But if you're averaging over the course of a whole month, that's a pretty huge anomaly. This is a look at how things ranked compared to other Februaries on record. So anywhere in the dark red had their warmest February on record, and anywhere in that second color of red, it was top 10 warm, with just a little bit of area in the southwest portion of the state, in Mineral County in particular, that wasn't quite as warm relative to the historical average, but still much warmer than normal. So the whole state kind of top 10 conditions. I should mention, since I show quite a few of these maps, that these data come from the National Centers for Environmental Information NCLIME Grid product. So these, you might wonder how we're able to make these spatially complete maps. We don't have weather stations everywhere. These maps use data from long-term weather stations and interpolate between them using things like satellite and radar data and physical relationships between things like temperature and elevation. All right, this is a map showing departure from normal temperatures for March. This actually isn't an NCLIME grid map. This is from the High Plains Regional Climate Center. But here, the main point is that we have continued the streak of above normal temperature conditions, with most of the state over 6 degrees warmer than normal for the first half of March. I'll kind of tease the later section of this talk and just say that that is likely to continue, maybe even intensify over the coming couple of weeks. Here is a look at precipitation for the month of February. And statewide, it was drier than normal, but you had anywhere from wetter than normal with some decent moisture in the Arkansas River Basin in places like Crowley, Otero, Bent, and Kiowa counties to much drier than normal on the northern Front Range and extending out over the plains. At our Fort Collins official weather station, we had 9 traces of moisture in February, but nothing that was actually measurable. So we were skunked for moisture up here in February. And then in the mountains, you see some areas that were near normal for February. But like I said, that's kind of a minor victory relative to a winter that has been full of defeat in terms of snow being much below normal, and we'll hear far more about snowpack later in this briefing from NRCS. Here's how February ranked compared to all the other years on record going back to 1895 using this NCLIME grid product. It was kind of in the normal range for a lot of Western Colorado, but again, that's one near normal month surrounded by dry months. And then it was much drier than normal for parts of northeastern Colorado. All right, this is just showing how we've fit in with the rest of the US over winter. So this is showing from the NOAA NCEI and Climate at a Glance product how statewide precipitation for this winter ranked compared to those other 130 years on record. It was the 15th driest for Colorado. You can see it was also a fairly dry winter for the other four corner states and dry for the Central Plains. All right, for this is month-to-date precipitation for March. And here the filled contours are the actual precipitation totals with each labeled dot showing an actual station measurement. And the kind of red and orange and yellow lines you see on there, that was just the US Drought Monitor contours, current US Drought Monitor. So they don't tell you anything about the precipitation that's fallen this month. It's just showing the current US Drought Monitor kind of overlaid on monthly precipitation. But we did have a good precipitation event the first weekend of March on the Front Range and Urban Corridor, and extending down into the Springs and Pueblo a little bit, and extending partially out onto the Eastern Plains, but not all the way out onto the Eastern Plains. Some areas getting as much as 1.5 inches of moisture, mostly in the form of snow. And if we look here, this is a graphic showing our March 6th and 7th accumulated snowfall totals from the Community Collaborative Rain, Hail, and Snow Network. And you can see some areas along the Front Range up towards Nederland and even up towards Estes Park with a foot of snow, and even some areas down towards the Palmer Divide also showing a foot of snow, and kind of a mix through the metro area, anywhere from a couple inches on the north side to 9 inches on the south side. So this was some good moisture, but we got a lot of questions during and after this storm of, how did it affect the snowpack? How did it change the narrative of of winter? And overall, this event brought some okay moisture to the northern Rockies, but did not make that much of a dent in the overall snowpack deficits that had already been accrued for the winter. It was more a Front Range event than anything else. This is kind of a fun graphic that we're now displaying on our website that shows it shows a number of things. I'll start with the top here, where we're looking at conditions throughout the water year, averaged across Colorado. And the first graphic that you're seeing there is daily temperatures, and the black line shows what normal would be throughout the first portion of the water year, kind of from the beginning of October through the first week or week and a half of March. And then the bar chart shows you the actual temperatures that we experienced. And you can see if they're shaded in blue and below that black line, they were below normal. If they're shaded in red, they're above normal. And the kind of how deep the hue is tells you how much above or below normal things were. And it's really striking looking at this that we have been above normal for temperatures, even on a day-to-day basis, for a very large chunk of the water year to date, including some historically warm temperatures throughout the middle and end of December. And then you can see January, we were a little closer to normal with a good cold snap near the end of the month. And then February, for the most part, much warmer than normal, with one little cold snap in there. And if you break things down month by month, it was the 11th warmest October on record, third warmest November, warmest December, warmest February, and then even January, 17th warmest, despite that cold snap. So we have been well on the warm side of the distribution. And then if you look at the graphic below that, it's showing a similar thing, but it's showing precipit. So the black bars at the bottom show you daily precipitation accumulations across the state. And then the colored bars above are giving you a running tab of how much above or below normal we are statewide for the water year. And you can see that we in the middle of October got off to a decent start with the statewide statistics, although the way that moisture fell was far from ideal because it was flooding in the San Juans and concentrated heavily on one portion of the state. And then since then, we've just fallen back and then further and further behind. So October was on the wetter side, but it was in fact quite dry. For the Eastern Plains, just that was more than offset by the flooding conditions in southwestern Colorado. And then since then, 41st driest, 30th driest, 28th driest, 33rd driest, and these are out of 131 years of records. So, not as striking as temperature, but still from a precipitation standpoint, we've been consistently on the drier side of normal since November. Okay, this is showing a couple just stats that stand out. And the text here, when it comes to temperature, and the text here on the left-hand side is smaller than I would like, and the legend at the top, in fact, got a little bit cut off, so I will fix that before submitting the final slide deck here. But here we're showing throughout different accumulation windows how temperatures compare to normal statewide, starting with just 1 month, looking at February. And anywhere in that red is where we have seen record warm conditions. So the top row is showing just for February. And then we sort of back things out from there. The second row is showing January through February, December through February, so a 3 month temperature window, then November, and so on and so forth, down to 12 months. And then we got a little less granular where we looked at 18-month, 24-month, 36-month, 48-month, and 60-month, or 1, 2, 3, 4, and 5 years. And so it was the warmest February on record, warmest January through February on record, warmest December through February, or climatological winter on record, and so on and so forth down the list 4, 5, 6 months, all the way down to 36 months. It's the warmest on record, at least ending in February. So this is just relative to every other period that's ended in February. The only time scale that we're not the warmest on record here, all the way back to that 5 year time scale, is the 4 year, because that gets in the influence of 2023, which was a cooler year, while cutting off some of the warmer conditions that we had before that. Now, the graphic on the right-hand side shows the number of days with a maximum daily temperature at or above 60 degrees for climatological winter or December through February for Fort Collins in the top panel and Akron in the bottom panel. And so the horizontal axis here shows you the year, and the vertical axis shows you the number of days that we hit 60. Now, for Fort Collins, you can see that we hit 60 over 40 times. I believe it was 43 times for December through February. And we had never had more than 25 60-degree days in winter before that. If you look at Akron, they hit 60 36 times, and they had never hit 60 more than low 20s before that. So, shattering records for number of 60-degree days in winter. And then if we compare that to conditions around the country, it's been a record warm winter across much of the South Central Plains, Intermountain West, even extending out towards the Pacific Coast, where Oregon had their warmest winter on record. And then even if we look at California, Idaho, Montana, and Nebraska, Kansas, those were second warmest on record. So yes, it was a cooler than normal winter out east, but we were breaking records out west. Okay, like I mentioned, we have had some windy conditions as well along with this. There's been a number of days that were not only warmer than normal, but windy. So if kind of looking through the daily maximum wind gusts from our COAGMET network or Colorado Agricultural Meteorological Network, most days in March to date, you can find wind gusts of at least 25, if not 30 miles per hour, somewhere in the state. And March is part of our windiest time of year in Colorado, so that's not particularly unusual, but we have had more than normal with some severe wind gust days, including this March 12th, which was last Thursday, where we had the downed trees and fences that I was showing in the cover slide. And you can see that this day in particular, the most severe gusts were kind of concentrated in the northeastern quadrant of the state, but other portions of the state have had some very gusty days this month. And this is the gusts from March 14th, or just 2 days later on Saturday. And you can see that it's less concentrated on the northeast quadrant of the state, that some of these gusts extend around the state. And if you look through some of these maps, there are some days where the gusts were more concentrated in the Arkansas Basin in the southeast quadrant of the state. All right, so that's it for current conditions. I will go ahead and transition into showing some of the drought conditions and drought metrics that we're looking at. We're not looking at snowpack here because NRCS will be showing that in just a few minutes here. But we'll start with a look at the current U.S. Drought Monitor map. Right now, the U.S. Drought Monitor is showing 64% of the state in moderate drought or worse. 80% of the state is in at least abnormally dry conditions on the U.S. Drought Monitor, with 37% of the state in severe to exceptional drought or D2 to D4. The U.S. Drought Monitor, for those who may not be familiar, is a product that's put out by the National Drought Mitigation Center at the University of Nebraska-Lincoln, and it's an appraisal of current drought conditions based on a myriad of indicators with kind of local expertise input in the weekly map drawing process. So it includes kind of the snowpack conditions, the temperature conditions, everything that we're seeing. You might be surprised that there's not more drought in southwestern Colorado, where we do have well below normal and in fact below 50% of normal snowpack in many areas. And I think that's because we had just been through a flood in that area prior to the snowpack season. So it's not necessarily clear how quickly to start to show more and more drought on the U.S. Drought Monitor map following an event like that. But certainly some interesting conditions with flooding in October, followed by near to record low snowpack. Here's how the US Drought Monitor has changed over the last 12 weeks. So, where you're seeing the warmer colors, the yellows and the oranges, that's where things have gotten worse on the US Drought Monitor map. And then the greens are where things have gotten better. You see a few areas where there's been some minor improvements, including some of the moisture that we saw in February in the Arc Basin. But for the most part, we've been seeing degradations over the last 12 weeks, which makes sense with the much drier than normal conditions and the record warm conditions this winter. Here is how things have changed over the last year. So here we can see that the drought in the northwest and north central portions of the state, Northern Rockies. Most of what you see on the US Drought Monitor was not there 1 year ago at this time. Most of it is either it's a combination of a hot, dry summer last year and a much lower than normal snowpack this year. This is a look at the standardized precipitation index over the last 90 days, ending March 15th. Standardized precipitation index, for those who may not be familiar, is just a metric that is designed to show us how rare is it for things to be either this dry or this wet, given the location and time of year, and it's measured in standard deviations. It's not quite that simple, but we won't get into the full computation methods here. Basically, what you need to know is areas that are in the greens and blues are areas where it's been wetter than normal over the last 90 days. You don't see much of that here. A little bit in El Paso, Pueblo County, extending into Lincoln County. And then areas in the yellows, oranges, reds are where it's been drier than normal. And in fact, those have been designed to kind of line up with the US Drought Monitor classification scheme. But we can see much drier than normal conditions across much of western Colorado over the last 90 days, and some bleeding into the northeast corner of the state, northeastern plains. And then this is the last year or so, so 360-day, approximately 1 year. And you can see here the northwest quadrant of the state and the northern Rockies really light up as being much drier than normal, if not record dry. I talked a little bit about southwestern Colorado and the dichotomy of really wet conditions in fall, followed by really dry conditions in winter. And this is just a graphic to kind of hammer that home, looking at precipitation accumulation from the upper San Juan Snowtell, which is near Wolf Creek Pass. The horizontal axis here shows you time of year, vertical axis shows you precipitation. And the red line or the kind of burgundy line shows how normal precipitation accumulation from October 1st through the middle of March. And the green line shows you what we got. So we were already at 12 inches of accumulation by mid-October due to those floods. But then with the dry conditions in November and December and January, we saw a little bit of reprieve in February, but again, dry in March. We've come all the way from over 8 inches above normal back to about 4 inches or 3 or 4 inches below normal. Here is a look at soil moisture for across the state using the Western Land Data Assimilation System product, which is a modeled soil moisture product that it's heavily based on satellite observations, but this is showing above normal soil moisture at high elevations and below normal at low elevations. What's going on here? It's a couple things. At high elevations, it's a combination of locking in wetter than normal conditions prior to the snowpack season, but also some early melt, particularly at middle elevations, where if you see higher than normal soil moisture this time of year, it's often a problem because that means that we're seeing snow melt earlier than we should be seeing it. And then The dry conditions at lower elevation, that's more a product of just the winter has been dry, less snow cover than normal, and so things have already dried out at lower elevations. And then we see kind of a mix across eastern Colorado, but we do see some drier than normal conditions, particularly in the southern and southeastern portion of the state. And then this is showing terrestrial water storage. This is a bit more complicated product. This is also from the Western Land Data Assimilation Systems. And this is a combination of snowpack, groundwater, soil moisture, and canopy moisture. Soil moisture and canopy moisture ultimately don't account for that much water relative to groundwater and relative to snowpack in the areas that do get seasonal snowpack. And so this is more than anything a reflection of the fact that groundwater has declined over time, at least according to um, satellite measurements from the NASA GRACE satellite. And so the areas that you see in red, that's where terrestrial water storage is currently lowest on record. It's worth noting here, though, that this product only goes back to the early 2000s, so we don't have the same period of record here that we do with some of our other products, like the Enclime Grid product. All right, so that is the drought update. With that, I will go ahead and show a few slides on where we may be going from here. So let's take a look at the spring outlook, and we'll start with the 7-day precipitation forecast, and you can see that there's almost nothing there. Uh, there's a little bit of moisture wrapping up over the northern Rockies this morning. What is being shown on this map is likely already passed, and there could be a little bit of moisture right at the end of the 7-day period as well. But for the most part this week, we're going to be looking at clear skies, high pressure, and much warmer, if not record warm conditions. And we'll get into that a little bit on the next slide. But many of us across the state could see 70s and 80s over the coming days, kind of Wednesday through this weekend, with some areas in the mid to upper 80s and even a rogue 90 here or there possible in lower elevations of southeastern Colorado and western Colorado, which it would be record early for some of those numbers. This is a map showing the height of the 500 millibar pressure surface. Don't have to know what that means, but this is a metric that atmospheric scientists look at because it corresponds to how warm the atmosphere is kind of at large scale. And some of these heights that we're seeing at the 500 millibar level are unprecedented for this time of year across the south and western portions of the US. So the bottom two panels there show how much, or let's see here. They show the margin, yeah, the margin by which the previous record for geopotential height of the 500 millibar pressure surface will be broken and how long that will last. The upshot here is that the records are likely to be significantly broken and may be broken for as much as a 5 to 6 day period. And so we're looking at a substantial heat wave or warm wave for this time of year, with highs again for many of us in the 80s coming up this week. And then if we look at the 8 to 14 day time period, that heat wave itself does get kind of broken up over the next week, the end of this weekend, tail end of this week into next week. The heat wave gets a little bit broken up, but builds back in to some extent, probably not as strong. But this is a graphic from the Climate Prediction Center showing whether we're expecting above or below normal temperatures and precipitation over that 8 to 14 day time frame. The left-hand side of the page shows the outlook for temperature, right hand for precipitation. And we can see that there is an increased probability of above normal temperatures across the entire state, especially towards the southwest end of the state at the 8 to 14 day time frame, and an increased probability of below normal precipitation. Um, I don't want to spoil too much for the next talk, but with our snowpack numbers and our current snowpack temperatures, combined with some of these much warmer than normal temperatures that we're likely to see, and the dry conditions that we're likely to see, it's possible that many areas of the state at high elevations have already seen peak snowpack. And that doesn't mean that moisture that we get later in the spring won't be important. Moisture that we get in April and May and even into June will still be crucial for our water supply, but it's possible that the very meager snowpack numbers you're going to see in the next presentation, that it could be as high as they get for this year. So, once you get beyond the 8 to 14 day range, our numerical weather prediction models descend into chaos, and we have to rely more on statistical relationships between the slower moving components of the climate system, like ocean surface temperature patterns, and how those tend to affect atmospheric patterns. And oftentimes, when we're looking at seasonal timescales, we're talking about what's happening over the Pacific Ocean in terms of El Nino versus La Nina. This is a map showing current ocean surface temperature anomalies around the globe, and typically we're honing in on the central and eastern Pacific. If you see blue colors there, that's typically indicative of La Nina or La Nina leaning conditions. Red tends to be indicative of El Nino or El Nino leaning conditions over the central Pacific. Right now, you can still see there's a blob of slightly cooler than normal ocean surface temperatures holding on over the central Pacific, and you can see warmer than normal starting to build in over the eastern equatorial Pacific. The upshot here is we were in a weak La Nina over the winter, but it's already dead by some measures. It's hanging on by a thread by some other measures. We are saying goodbye to La Nina, though. We can be very confident that it is going away. Can't be as confident that it will be replaced by an El Nino, but we are under an El Nino watch for this summer into fall. This is a graphic that shows the probability of La Nina or El Nino by season. The horizontal axis shows you time of year, starting with January, February, March. Two bars over from that, MAM is March, April, May. And then you can kind of go from there. Each bar shows the next month in time. And then the vertical axis shows you probability, and the colored bars show you the probability for each phase, each ENSO phase. So blue shows probability of La Nina, gray shows probability of ENSO neutral conditions, and red shows probability of El Nino. So we had a La Nina, it's wrapping up, it's either dying, if not already dead. We're going to be transitioning into ENSO neutral conditions for the spring, and we could be seeing there's about a 60% chance, if not a little bit higher, that we'll see El Nino by sometime this summer or fall. It's a good thing that La Nina is dying when it is, because La Nina tends to be associated with both warmer and windier than normal spring, or sorry, drier and windier than normal springs in Colorado. And we could definitely use the moisture and use a break from the wind. This is a correlation analysis showing by season how our precipitation across the state tends to vary as a function of La Nina or El Nino. Areas in blue are areas where it tends to be wetter during La Nina. Areas in red are where it tends to be wetter during El Nino. The upper left-hand panel shows winter, December, January, February. Upper right, March, April, May, or spring. Lower left is summer. Lower right is fall. Couple things here. For most seasons, it tends to be better for us if we have El Nino conditions, but it's not a guarantee. The El Nino versus La Nina will give you an idea of how it's kind of like playing a game of poker where you have an idea of how the deck is stacked, but it doesn't tell you what hand you'll get. You can have the deck stacked in your favor and still draw a crummy hand, and that's kind of what we saw in the Northern Rockies this winter. So if you look at the upper left-hand panel, this is actually a good representation of the uncertainty here, where the Northern Rockies tend to be wetter during La Nina. But we had La Nina in place this winter, and it turned out to be a total bust. So just because the deck is stacked in your favor doesn't mean you can't draw a 2/7 offsuit. All right. With that in mind, here is a look at from the Climate Prediction Center at how temperatures and precipitation across the state may whether we have an increased probability of above or below normal temperature or precipitation. So on the right-hand side, you see the probability of above or below normal temperatures. The left-hand side is temperatures, right-hand side is precipitation. And so we can see that the whole state has an increased probability of above normal temperatures and below normal precipitation for the spring. This is based on a few things. One, even though La Nina is dying, sometimes we do see lingering impacts from La Nina going into the spring. It's also based on trends. So, particularly in the southwestern US, we do have a trend towards drier than normal conditions in April, May, June. And then throughout much of the western US, we have a trend towards warmer than normal conditions over recent years and decades in April, May, June. So, it's based on both lingering La Nina impacts and trends, as well as output from dynamical models that try to simulate the weather a bunch of different times over the course of the coming season. And there will be this is really important. There will be an update to these graphics in 2 days. So this was issued in the middle of February. There will be an update to these this Thursday, and the situation has changed when we look at La Nina versus El Nino. So these graphics, there's a chance that they don't look quite as bad when they're updated in a couple of days. I'll be really curious to see the update here. So then if we look forward to the summer, I was looking at some of these longer term seasonal forecast models and just looking for any sliver of hope that I can end this briefing with. And more of these models, these seasonal forecasting models than not, do show uh, potential for a wetter than normal summer, that June, July, August timeframe, particularly over western Colorado. Having said that, some of them do show drier than normal on the eastern plains. So we'll see what happens there. Still quite a bit of uncertainty there. But with an El Nino watch going into summer, maybe things turn. Maybe we get an active monsoon. Some of these models are showing a better than normal shot of an active monsoon this summer. So maybe a little bit of hope there, but based on the 3 month outlook and especially based on the more near term outlook, I think that it's likely that things get worse before they get better. So I'll sum it up there with just a couple takeaways. Warmest February on record, warmest climatological winter on record, December through February, going back to 1895 for Colorado. Well above average temperatures have continued into March, with the first half of March being as much as 6 degrees Fahrenheit above normal statewide. And that'll potentially get even worse with the historic heat wave or warm wave that we're likely to experience later this week and weekend. This is especially alarming with snow in the high country already starting to show signs of getting ready to melt. And then we've seen more than our fair share of gusty days, even for a typically climatologically gusty time of year. From a drought standpoint, most of our state is in some level of drought, especially western Colorado, especially the high country, where we do see the well below normal snowpack that you're about to hear more about. And then, despite La Nina conditions breaking down, we do still see an increased probability of warmer and drier than normal conditions persisting through at least the next couple of months. But the odds of those conditions persisting looks like they might start to break down a bit once we get into summer. So I will go ahead and leave things there. Thank you so much for your time this morning and happy to take any questions. Again, wish I was giving better news.
Thanks, Peter. Any questions? I don't see anything in the chat. Um, Looks like there's a question, Peter, about a super El Nino. Um,
So I have seen that some of these ocean surface models, well, for one, more of these model runs than not are showing El Nino development. That's why uh, there's approximately a 60 to 70% probability of El Nino developing. But some of these models go big with El Nino development. And so you will see some kind of chatter about the possibility of a large El Nino event. I'm not sure what the threshold is in terms of sea surface temperatures for being a super El Nino. I can go ahead and look that up for you, but I'm not sure what the exact probability is of it being a super El Nino, but there is a chance that we have a significant El Nino event. What that means for Colorado precipitation and temperature isn't completely clear either.
Great. Thanks for the question and thanks for the answer, Peter. For the sake of time, I think any further questions, I just direct you to put them in the chat so that we can move on to NRCS. Thank you again, Peter. And I will pass it over to Brian.
Yes, Emily, good morning,
Good
everybody.
morning.
And thank you. Let me take over here. All right, as I'm getting started, let's first make sure that y'all can see my screen
Yep.
and you see the main presentation view, correct?
Yes.
Okay, perfect. Few uh, kind of administrative pieces this morning. One, forgive me, our bandwidth here is quite slow, so I'm going to leave my camera off. Fortunately, over the last 30 minutes, it seems my connection has been a bit more stable, so hopefully there's no issues and we can get through this without a problem. The next little thing to mention is, unfortunately, on Friday, IT migrated our entire database and all of our tools, and some of them did not migrate as intended. So on Monday, yesterday, when I was creating the presentation with the most up-to-date data, I had to do a little bit of workaround to get it working. Good news is most of the tools are now back to working as of this morning. Any APIs and data calls, Python scripts that people may have written, that's not entirely working for me at this point. It seems to be working for others. And a few other tools are still down, but I think most of those are behind our firewall. So hopefully, any tools that you go to access are now working. If not, please reach out and let us know. Last little administrative item. I need to run at 11 to provide another presentation. So as Emily was saying, if there's any questions in the chat, I'm happy to take those, or any verbally, if there's time for that, I can take those up until 11. Okay, getting started. So zooming out from where I typically start the presentation, wanted to look at the entire Western United States and what we're looking at snowpack-wise. We're not the only one to be facing for snowpack here in Colorado. Sorry, given the shading, it's a little bit hard to make Colorado out, but we are in this area here, right? The rest of the country is looking pretty poor for snowpack, all the way up into Oregon, one could argue into Washington and Idaho. We've got well below normal snowpack through most of California, Oregon, Western Idaho. Only Montana and north of, say, the Tetons, parts of Montana are somewhat more near normal, but we are not the only ones to be facing poor to very poor snowpack here. I've heard a fair amount of discussion about what role temperatures have been playing on mountain snowpack, and it has no doubt been an impact here in Colorado, but I would argue not as much of an impact as we have seen in northern and northwestern United States. So the next graphic here is showing what nationwide SNOTEL precipitation is, and you can see that the picture is much, much different. We have actually normal to slightly above normal precipitation in the northern U.S. and even in the western portion of the mountains. Snow or precipitation is still pretty good at close to normal or above normal. So going back to that previous graphic, you can see that we've got yellows, 80% of normal, 70% of normal, even 30s, whereas the precipitation is near to above normal in some locations. So the temperatures have been impacting them in the northern portion of the country significantly more than I would argue here, but we still are seeing those impacts of the above normal temperature. And I'll kind of get into that here in a little bit. Okay, so focusing in on Colorado, this is snowpack as of yesterday morning. This graphic did update. I will get into some of the other graphics that I have here that did not update right away and kind of how we'll look at that to bridge that 2-day gap. But snowpack across much of the state is well below, across the entire state is well below normal. When you get down into the San Miguel, Dolores, Animas, San Juans, and Rio Grande Basin, we're looking at snowpack below 50% of normal. In the central portions of the state, and slightly further north, things get a little bit better. We're still looking at 65% of normal, but what's important here is to look at the snowpack with respect to percentile or ranking, and that's what I'm going to show here in a little bit, is where the snowpacks rank for the individual basins. What I'm doing here is I'm comparing snowpack change from the 1st of March through yesterday morning, just to get an idea of how snowpack has changed. Have we seen much melt? Have we seen any improvement anywhere? And I think what's most notable is if we look here, this is the beginning of the month, March 1st. Snowpack in the combined San Miguel, Dolores, Animas, San Juan Basin and the Rio Grande were a bit above where they are now. We have seen some decline in snowpack, particularly at the lower elevations. And that's one of the most important things to point out here is we are seeing melt at the lower elevations, depending on where we're at, 9 to 10, maybe up to 10.5. But once we get above that, we're not really seeing that much of a decline, just not as much accumulation of snowpack. I have not been out recently to actually look at snowpack to see if it's actually isothermal. I know when I was out at the end of February, snowpack was not isothermal, and isothermal means all one temperature. Snowpack almost always does not melt until it is isothermal, particularly here in Colorado. Was not seeing very much of that in early February, but as of late, I would guess that at those lower elevations, kind of like Peter was mentioning, we're looking at snowpack that is melting at those lower elevations. I would guess about 10.5 and below, and that also depends where you are in the state. I would say in the San Juans, we're probably looking at melt maybe a little bit higher than that. But I know that the northern mountains typically hold on a little bit longer, and you will see data here that actually shows that it is holding on. So not much of a change in the Colorado headwaters from March 1st through yesterday. Not much change in those northern mountains, but when you get into those southern mountains, we have seen a bit more change the further south you go. And then drilling down deeper into those sub-basins, you saw that most of the stuff in the south was well below normal, below 50% of normal snowpack, but just kind of driving down into those individual basins, you can see that, for example, the Arkansas River Basin was 50% in the last graphic, but as we break it down more specifically into the subbasins, those subbasins to the south are particularly low on snow, almost melted out. But the upper Arkansas is holding on a little bit more. Elevation is a big driver there. Just a lot more snow is typically held, a lot more cold content. Even in a low year like this, you're seeing a lot more cold content in the upper arc. Because the database was not updating as of Monday morning for the most part, and most particularly the graphics that I'm going to show after this, the time series snowpack graphs, those were not updating as of yesterday afternoon until late. And so the snowpack graphs are 2 days delayed, well, technically 3 from today, but from yesterday when I updated this, I wanted to give an idea of what changes had occurred and where it was. And as we cycle through those upcoming time series snowpack graphs, you can get an idea of what has changed in that black line that we'll see, that the time series, the current line for 2026. So from Friday afternoon through Monday morning, this was the change, and we could see it in the map. Fortunately, you can see that there was some accumulation of snow water equivalent in the Front Range mountains, in the Park Range, a little bit in the flat tops, and just a little bit more on the Grand Mesa. Everywhere else was largely seeing a decline over the last 2 days. Some of the upper elevations in the San Juans saw a little bit of an increase in snowpack, whereas most sites were seeing a decrease in snowpack. So let's keep that in mind as we move forward into these coming slides. This is the entire state of Colorado snowpack time series graph. So as of the 14th, snowpack was 59% of median for the entire state of Colorado. You can see that there was a slight downturn over those 2 days, and that's probably based on what we had seen in mainly the San Juans and the Sangre de Cristos in the southern mountains of Colorado. And in general, I was able to update this graphic this morning. Unfortunately, I wasn't able to put it into this presentation, but there was, I think, a 1/10 decrease. So I think we're at 8.1 inches of snow water equivalent as of this morning. Somebody can check me on that. I went through a bunch of graphics this morning and trying to troubleshoot some IT issues. So you can see the massive deficit of snowpack where we're at. Typically, we should be right here, this green line, and we are all the way down here. The big thing to point out with these graphs is how low we are. So I don't have it on this particular graphic, but through the rest of the slides, I have the number of years in the period of record for the particular data set that was used to create this graphic. And in this case, I think we're at 41 years for the state of Colorado. This low line here is 2002. As you can see here, it blends in a little bit and gets a little on the dark side. But 2002 was the minimum year prior to 2026. Now we're looking at the record low snowpack at this point for the state of Colorado. Projecting a number of the low years that we've seen in the past forward, such as 2018, 2012, and 2002. You can see those lines here, and then the dotted lines are the probabilistic outcomes based on what has occurred in the past. The dotted green line being the 50% or the median outcome going forward would indicate that we would gain some more snow up until our snowpack peak on or around April 7th. Now, Peter gave a great outlook earlier in his presentation that, in my opinion, largely indicates we are not going to see snow accumulation anywhere near the 50% projection. We're probably looking at something in between the 30 or the 10%, maybe even lower. I do not disagree with Peter that in some basins, we may have already seen our snowpack peak. We are flirting with that right now, and I will continue to get into that in future slides here. But you can see that right here, we actually already have seen a peak. Now, it is noteworthy at this point in the year that particularly this early, it is possible to wind up seeing multiple peaks because there is still the possibility of cold temperatures and more snow. The question is, much as Peter was referring to, is how likely is it? Right now, it's not looking particularly likely, but there are a number of years in the past where we have seen snow persist out beyond, or snow accumulation increase going forward. Of note is 1981. I'll show that here in this next graphic. So this is a graphic that is supplementing the last one that I showed. Those AWS plots, which is not this one, it's all the other plots. The AWS snowpack plots do not have 1981 in it. I was able to create this tool to show 1981 being the lowest year that we've seen, even in the snow course data. I'll get into that here in a little bit. But you can see that we are above 1981. Now, I was not able to update this. The IT issues that we're having in our backend and database, this is one I'm still trying to work through, was trying to work through it this morning and unable. But if we use the changes that we saw in the last graphic where we saw a slight decrease in snowpack, I would guess that snowpack is now about here. It's decreased a little bit. Whereas, as I just mentioned, in 1981, we saw a real uptick, a real change in the weather pattern. Whereas I recall, if I did the math right, we received about 140% of normal snowpack from about March 1 through about the middle of April. So it is possible, but it doesn't look very likely based on the forecast model runs that I was looking at this morning and the seasonal and more shorter term outlooks that Peter was showing. So my guess is we will continue to stagnate, or this line will remain relatively flat or with a slight decrease, at least into the next week or two, and we will probably surpass 1981 as the lowest year by somewhere around the 20th, 21st, or 22nd, depending on how things go. This is the snow course data that we collect on a monthly basis. So the next time we will update this is basically at the end of March. Data will start to trickle in that last weekend in March, but it should really be completed about first week, about the 1st of April. So at the end of February, we received some better precip, which helped out a little bit, but we still wound up being very slightly below 2002 on March 1st and well above 1981 and 1977. One thing to point out, as I mentioned earlier, 1981 from March 1 to April 1 received some pretty good snowpack accumulation. So you can see it went from 4.3 inches of snow water equivalent to 7.4 inches, whereas 1977 did not so much. It did not see that same increase, and you can see that here in this graphic. So that would be the year to compare come April 1 to see where we stand with the longer term period of record. This analysis, I used, I think, about 40 sites, snow course sites, that go back to 1940, and 1977 is the lowest year, followed by 1981 starting in April. So that is the year to compare to for the monthly data in the longer term period of record. 1977, we did not have any, technically at all, snow tells in 1977, which is why the data does not go back that far. So with the change in database on Friday, these graphics, which I have been showing in the last two presentations, or last presentation, have not been updated. So we'll use a different method to determine where the current basins rank. And that's just by looking at the current line denoted in black here. If it's below the red shaded area, then we are record low based on the period of record. So I'm going to go through all of the 8 major basins in the state and just go over if we're record low snowpack or not. I think it's worth saying, and much as the way Peter mentioned it, the entire state of Colorado is very poor for snowpack. There is no basin that is looking good. In many years in the past, Colorado does have a few years that where the northern half of the state will be doing well for snowpack, or the southern half of the state will be doing well. That is not the case here. The entire state of Colorado is doing poor for snowpack. So going to the Arkansas River Basin, 35-year period of record, 2000. I believe it was 2002 is the lowest year, and I changed the graphics up a little bit later so it'll be easier to reference, but we are looking at the record low snowpack at 48% of median in the Arkansas as of the 14th. Colorado headwaters, 65% of median snowpack. It is still record low, and that is a 41-year period of record there. The Gunnison River Basin, as of the 14th, was 60% of median snowpack and was tied for the record low. And I think it has now, as of this morning, I think it is now record low, starting on the 17th here. The combined Laramie North Platte Basin is not record low, 74% of median. It is creeping closer in the update as of this morning, but was, I think, second lowest here, or third lowest, I should say, excuse me. The combined San Miguel, Dolores, Animas, San Juan basins, 50% of median snowpack, and it is the lowest by 0.2 of an inch of SWE below 2018. South Platte River Basin, fortunately, this one does go back 46 years and does include 1981. The South Platte is, as of the 14th, was 7.7 inches of SWE. Record low was 7.4, and as I recall, I think it's still 0.4 of an inch as of this morning above that 1981 record low. So we're holding on. My guess is that the South Platte will continue to hold on because of the higher elevation. I think the warmth that we're going to see over these next few days will degrade the lower elevation sites, but the upper elevation sites will hold on. One of the rules that I learned is if the overnight temperatures get into the 40s or 50s 3 or 4 nights in a row, that's where we will start to see more melt, or the snowpack at least turn isothermal at the given elevation. But that is something we'll have to monitor and watch to see what those temperatures get at those upper elevations, to see if that snowpack really does turn over, because that would be a big turning point for the South Platte if it does happen. And many of the upper elevations, even the Colorado headwaters, those rules kind of still stand. Upper Rio Grande, record low snowpack by 0.4 of an inch. And the Yampa White Little Snake, 66% of median, is again looking at the lowest snowpack on record. So wanted to highlight all of the sites that are seeing record low or second lowest snowpack on record. The particular graphic here that I pulled up is all sites with a minimum of 20-year period of record. All of the sites indicated in red are record low snowpack. All the sites in orange are second lowest snowpack on record. And you can see that there's a fairly even distribution of record and record low snowpack sites across all of Colorado. I also thought that it was interesting. I changed this metric to a minimum of 5 years in the period of record, and we had 74 sites that were either record low snowpack or second lowest snowpack on record, and that's out of 118 total snow tells in Colorado. So more than half of the sites are record low or second lowest snowpack on record. As I mentioned in the beginning of the presentation, looking at the northwestern portion of the country, where temperatures have played a bigger role in how much snowpack is actually out there, I wanted to do that with some tools that we do have existing and are currently working right now. As of March 1, using SNOTEL and SNOCORS data, we can look at the distribution of site elevation and what the percentage of snowpack is as a percent of median. And the trend line here tries to suss out, is there any trend? Are we seeing snowpack being more at the higher elevations or at the lower elevations? When this line is relatively level, like it is here, it indicates that there's not really a bias or a influence of higher snowpack at the upper or lower elevations. If the snowpack was higher at the upper elevations, I would seek a little bit more solace, or I'd find a little bit more comfort in that, because there's typically more snow that is held at the higher elevations than at the low elevations. If there was more snow at the lower elevations, that would be worse. The hydrograph would be even less. We'd have less in the runoff hydrograph that we would have in this particular basin, or excuse me, over the entire state of Colorado, which is here. We're not seeing a particular bias to more snow at the higher or lower elevations. But as we look at some of the individual basins in the state, such as the combined San Miguel, Dolores, Animas, San Juan, the Arkansas, and the Rio Grande, there is a slight bias of more snow at the upper elevations. Now, I do call it very slight. This line here tends to be a little bit more exaggerated, I would argue, but there does show to be a little bit more snow at the higher elevations, which is not very surprising with the warmth that we've seen at the lower elevations. It's a little bit more comforting to know that there is a bit more snow at those higher elevations as opposed to more snow at the lower elevations because we just typically, it's colder up higher, right? Whereas in the Laramie and the North Platte Basin, there is a slight bias towards the lower elevations. But because that's the main snow holding capacities, I actually think that the runoff efficiency could be a little bit lower in the Laramie and North Platte because of this negative tilt. Okay, looking at precipitation, mountain precipitation at our SNOTEL sites, we are looking at the numbers being a little bit better. So for the entire state of Colorado, precipitation is 81% of median. We are not record low there. So we're looking at 12.7 inches of water equivalent, and 12.7 inches of total precipitation as of March 14th. And again, it was the third lowest year in the period of record. That's in a 41-year period of record. Okay, getting back to the maps here. Colorado year-to-date precipitation, again, as Peter pointed out, and I'll highlight here, the San Juans saw that October storm, and that's what made a big difference across the southern Colorado. And then kind of highlighting how big a role that storm played, I removed October precipitation from the entire graphic here, and you can see, looking at November 1 precipitation through today, you can see how different those numbers are in the San Juans for year-to-date precipitation, 66 in the combined Southwest basins, 68 in the Gunnison, and 60 in the Rio Grande. I'm going to go back to that previous slide, and you can see that there's an improvement of 25 to 20% in those southern basins, where most of the northern basins do not see anywhere near as much of a change. Neither does the Arkansas either. Okay, Colorado month-to-date precipitation. Peter highlighted a storm or two over the course of March that showed some improvements in some locations, but you can see in large part most of the precipitation that we've seen in Colorado through March has really been focused on the Front Range and the headwaters of the Colorado River Basin, and then not so much anywhere else really, left high and dry in the San Juans and even in the Northern Park Range. Sangre de Cristos have also been left out. Quick highlight of soil moisture. I'm glad Peter hit on this already. What we're seeing at our mountain SNOTELs is exactly what Peter pointed out. We are starting to see melt at those lower elevations, and that's why we're seeing percent of normal soil moisture being so high for this time of year. This is the 8-inch soil moisture sensor. You can see that it's clear in most of those southern basins. We are definitely seeing a response to melt, even at some of the mid elevations, I would argue. However, the northern basins, again, with the dry spring and just still being cold at those upper elevations, we're really not seeing much melt at many of the sites. But the Yampa White and Little Snake being a little bit lower elevation, it seems that we are seeing some melt there at the 8-inch sensors. And then also at the 20-inch sensors, we're seeing some infiltration in those more southern basins just because of the warmth that they've seen, not so much in the north. And I also think that we're not seeing much at all in those higher mountains in the north, and that's why these are near normal. Okay, moving into the last few slides here. Statewide reservoirs as a total is 87% of median as of March 1. In the western portion of the state, about 80 to 85. So I'd say 80 to 90% of median, and then a little bit closer to normal in the Front Range reservoirs, better in the Rio Grande, but things have been running higher in the Rio Grande for the last few years at this time. And then looking at reservoir storage, the state of Colorado as a whole, cumulative over the longer term period of record, you can still see that we are well below normal, or below normal, and have been for a few years now. But the Colorado headwaters was a bit higher and is also still drifting downward. And then the combined San Miguel, Dolores, and San Juan basins have come up a little bit over the last few months. Stream flow forecasts as of March 1 were all poor, worse in the southern half of the state, a little bit better in the South Platte, and then still quite poor in the center part of the state. Not too much to comment on here. Trying to save a little bit of time, I'll step on to the second to last graphic here. 3 of these graphics here indicate our guidance forecast. This is something that we use internally to get an idea based on what the automated forecasts are indicating based on what conditions have transpired over the last week. I think with the databases being down this weekend, these tools did not update, but we do have an update through about the 7th, I believe it was, 7th or 8th, on 3 of these graphics. And what we can see in, at least the Rio Grande Basin, you can see that there was a downward trend based on what we have seen in terms of conditions from the beginning week in March. However, some of those storms that we saw in the northwest corner of the state and in the Colorado headwaters, and I believe even portions of the South Platte, did see an uptick based on some of those storms. We had seen, my guess is that given the change that we saw last week, all the basins but the South Platte and maybe the Colorado headwaters will probably see a downturn. And then with the weather forecast that we've seen through the rest of March from this point, we're probably going to see a downturn in those forecasts. And we were able to run mid-month forecasts for South Platte. These were able to get updated yesterday, so fortunate for that. You can see that the South Platte has remained relatively stable. So sorry, what I mentioned earlier, I forgot I had the South Platte in here. So at least based on what we've seen over the course of March so far, things aren't looking so bad for forecasts, but I think they will continue. They will return to a downturn at the end of this month based on the forecast that we're seeing. So quick wrap up. Snowpack in Colorado is the lowest in the about 40-year period of record, but still better than 1981 based on some different analysis. Snowpack is currently at 59% of median. I did a quick look, and at this point, through the remainder of the typical snowpack accumulation season, we typically get about 13% more, or 13% of our total snowpack is received from here to the end of the snowpack peak, which is usually about April 7th. So point being, we have very little winter left. There's essentially no chance for us to get back to normal snowpack. The question is will we get back to the minimum snowpack that we've seen in 2002, 2018, or 2012? Exactly where will our snowpack be? Statewide precipitation is at 81% of median as of the 14th. Statewide reservoir storage is at 87% of median, and stream flow forecast, we're all below normal as of March 1, and given the forecast that we're seeing, we're probably looking at a further downturn in the stream flow forecasts. And that is all that I have. Sorry, it's not any more positive.
Yeah, I wasn't expecting super positive presentations this morning, but thank you for providing the detail nonetheless. I think there's a good question from Nick Harris from Colorado Springs Utilities in the chat, and I'm wondering if Peter or Brian could speak to, well, maybe not speak to, maybe write it in the chat, because I do want to get to the updates from you all. But he's asking about the likelihood of multi-year snow droughts. So maybe Peter and Brian, if you could write, your thoughts on that in the chat, that would be awesome. And I think now I would like to turn it over to you all with updates. If you're a water provider, municipality, water manager, we'd love to hear, not only conditions at this point, but kind of if your area or region has gone into, drought watch or drought restrictions. We'd love to hear about that as well. So I'll open it up to you all.
Hey,
Nathan
Emily.
Miller. Oh, go ahead.
Oh, I'm so sorry. Hey, this is Melissa Owens with Aurora Water. I just have a really quick update. Our storage is at 58%. Snowpack, I know we know is low, but the basins we're focusing on are at 55%. And of course, we are talking about drought restrictions and don't have a timeline of when that's going to happen, but that is being discussed. And that's all I had. Thank you.
Thanks. Go ahead, Nathan.
Yeah, snowpack that we monitor for South Platte is no surprise lowest that we've seen. A little bit better on the Colorado River side, but still the third lowest there in that snowtail record. Our storage is 80% full. Normally for this time of year, we'd be 85% full. So it's not so bad right now, but we're looking ahead to this summer and seeing the stream flow forecasts. Really low likelihood of filling, and we think we'll peak somewhere in between 75 and 86% full. So with that, we're skipping our drought watch this year, and we'll be going straight to stage 1 mandatory water use restrictions through the 25th.
All right. Thanks for the update.
Hey, Ethan Bravo with Colorado Springs Utilities. Our current storage is as of 77% of capacity. Normal will be 75. We keep watching the weather and precipitation. However, we are not on any type of restrictions at this point. Again, our snowpack it's low in most of our watersheds where we divert water from. The forecast seems to be less than 50% of yield compared to previous years. So we just continue watching the weather and further plans will come later on.
Sounds good. Thanks, Eitan.
Hello,
Hi,
John
John.
Orr from City of Thornton. Our storage is currently just under 83%. We're in real good condition going into the summer. And currently consumption is 2.83% below last year. And so that's a good sign going into restrictions. Our council passed the resolution for stage 1 drought response last Tuesday, and our drought rules went into effect March 15th. So all the things that go along with that are happening now. And we're hoping to get good reductions in consumption by our customers, because you're never diverting for the current year. You're always diverting for the next year. So, and our projection for next year, June or so, if we have a good winter or a good winter next year, still are not that positive. So reductions are in order if you live in Thornton.
Sounds good. Thank you, John. Swithin, I see you're off mute.
Yes, so for Highland Ranch Water, our storage is at 61%. It's held there steady for the past couple months. Our use demands have been higher through the winter, primarily with commercial irrigators and say the Parks Department, golf courses, those kind of things. We have encouraged our residents to water their trees over the winter, it being so dry. Snowpack is of course concern to us all, but we did start in December. We've been pumping groundwater since December to try to preserve the surface water in our reservoirs for the summertime surge. So we did declare drought watch. That was effective March 1st. We're still in that. I am not at this point seeing moving that prior to April. Either way. Waiting to see what happens. We were lucky enough to get some moisture in March, 2 good events, which just shows that making moves towards enacting your drought plan always is helpful to bring moisture.
Very true. Thanks, Swithin.
Hello, good morning. It's Adriana with Castle Rock Water.
Hey, Adriana.
Hi, I was just saying that our storage is also at about 80%. We are not currently in any restrictions, but we have recently had a meeting with all of our internal departments to discuss upcoming operations and how we can coordinate that with the likely drought stage restriction coming up here in the early summer, late spring. So more on that to come.
All right, thank you. Anyone else? Anyone from West Slope?
Hi, I'm Beverly Richards with the Upper Gunnison. We do not have any drought watch or drought restrictions in place at this time, but they may be coming down the pike. Our storage is currently 53%, but that's pretty normal for this time of year. However, we did meet with the water users for Taylor Reservoir, and based on the forecast, we did reduce releases out of Taylor Reservoir in order to maintain some storage at the end of the year because it looks like they're not going to get much water in that reservoir. So we have implemented that, and that'll run through May 1st.
Okay, thank you, Beverly. Anyone else? Well, I guess I'm hearing none. I see in the chat that I'm not sure Nick's question was yet addressed, but it seems like Brian's popping in some info in the chat. Nick, if you just want to follow up with me via email on that question, I can point you in the right direction. So I think that will conclude our March meeting. Thank you all for being here. Yes, Adriana, I can add you to that thread. And our next meeting is in April on April 21st. Yep. So I will see you all then. And thanks again.
Thanks, everyone.
See ya.